Hi everyone, and welcome to this third episode of this Git series where we try to implement Git in Scala. In the first two episodes, what we did in the first episode, we implemented the first piece of business logic, which was about blob hashing, which is one of the fundamental piece of Git, I believe. But now we wanted to add another feature, hashing a file from the file system. So instead of giving a string that we want to hash from the std in, we want to give like a file. It's another option that we want to give to the command. And knowing Git, we saw that it's going to start to have a series of features, and for each feature, different options that we want from the command line. We started to integrate the concept of command. This command contains all the command line options. So this command allows to have a bit of a clear expression of the user intent. And then we also introduced the use case. So basically every business logic group, like every business logic feature, is going to be inside of a use case. For the moment, inside of the use case, we just have this logic of blob hashing. But eventually, we are going to grow this logic specifically for blob hashing, for instance, by adding hashing a file from the command line. And then we're going to add more use cases to grow the set of features. In the second episode, we refactored the project to use hexagonal architecture. We want to do so in order to have the business domain in the center of the software. And after all, the command line is just a detail of implementation about the way we interact with the business logic, but we can imagine as well to have an HTTP API, for instance. And this architecture allows us to focus on the business domain, the piece that is the most important in the software, the piece that brings business value. So I think it's relevant in that case to focus on that. In the future episode, we are going to see that we are probably going to need some interaction as well with the file system. We could imagine having other implementation for that as well, using S3, for instance, instead of the file system. So that's why I thought that having hexagonal architecture would be a good idea. And the next thing that we wanted to do here is to add ZIO. So I chose ZIO here because it's a simple tool that is going to allow us to handle the resource. The resource is in a nice way, so making sure that we are closing the resources. There is also some streaming features that we are going to use probably to read the files. And I imagine potentially retries and parallelism. But so for this episode, we are just going to integrate ZIO, which is going to require to change the files to use the ZIO test and the ZIO main. So episode 3, add ZIO. In the next episode, we will probably hash a file from the file system. So let's get started. And if I open build at SPT here, you can see that I have added ZIO, ZIO test, and ZIO stream. And just recently, the 2.0 was released, so I'm going to remove the release candidate here, and I'm going to reload. With this kind of refactoring, what can be important is to always try to have a version that compiles. So I think we need to be a bit clever about where to start the refactoring. if we start the refactoring from the center, we are not going to be able to compile until we fixed everything. But if we start the refactoring from the outer layers, it's going to be easier to refactor and still compile and still have a confidence that the software still kind of work. So I think it's a good way to kind of progressive refactoring, not too much of a big bang. And we are going to start by this test here. So we are not going to use Scala test anymore. We're going to use the ZIO test. So instead of flat spec with matcher, we're going to use ZIO spec default. This is the new name of the test that of the class that we need to extend in order to use the test in ZIO 2. And this is an object here. I'm going to help it a bit to import things. So ZIO test. Okay, so now IntelliJ imported that. So I'm going to comment that out for the moment. And I am going to implement the spec. So the spec is kind of the method that we need to implement in order to write the suite of tests. So I think we need to specify the suite. So I'm going to say HashObjectUseCase. And then we're going to specify the test. So in the ZIO 1, it used to be test M, I think, but now it's test. And we are going to say to the hash test content. Okay. And what we can do first to check if it works is no, it's assert true equal to true. Let's see if we can run this test. Okay, so we can see that I forgot to import ZIO assertion as well. Okay, so we can see that the test is passing, which is great. I might try to run it with SBT because, as you can see, it took quite a long time. Okay, and can we just run this test? Okay, so that's interesting. We can see that notice was picked up. And looking at this spec, we might need to specify. So in the spec, I just copying here from the spec. So saying that we need to specify that. So what I might do is might rename that. No, actually, I'm going to keep the name for that, but I am going to name that use case proxy, and I'm going to put that here and see if we can put, okay, still not picked up. I'm using objects. Oh yeah, actually I need to use run main. So test/run main. Because somehow it's not picked up by the SBT test yet. Yeah, and when we use run name, we have to use explicitly the package. So I'm gonna copy and give the full name for the class that I want to run. Yes, and we can run the tests. Awesome. I'm gonna try to use Bloop instead because SBT is super slow when I'm recording. So Bloop, I think the way we do it is run test, no, it's root test minus m and specify the same. No. Okay. So we have the same result as well. The test obviously passes. I hope that this is going to be integrated properly in Bloop and SBT eventually, because that's very inconvenient. Okay, so going back to our test here, what I'm going to do is I'm going to use for comprehension, maybe not, maybe I don't need that actually. So I'm just going to copy that and say that it should equal to this string, right? Okay, so it seems to be working here. I'm just going to change the output to verify that the test is actually running as we want. Okay, and here we have the error that the hash doesn't satisfy the one we wanted, so that's good. I changed this Scala test to a ZIO test, but the goal is to have the handle command as a ZIO, okay? So what I'm going to do is I'm going to do succeed, and I'm going to wrap this into a succeed and see if it still works. So as you can see, I'm going in a very baby step way. Obviously, eventually we don't want to have ZIO succeed here. We want to have the handle command that returns ZIO directly. But just checking that if we give a ZIO to that, it's gonna work. Okay, so we can see here that I need to probably use a flat map or a map because the ZIO didn't run here, so it was like taken as a value. So I'm just going to create a for comprehension and which one is it? Probably this one. Hashed, and this is the content. And we are going to yield the assert hashed equal to that. So now we should be better. Let's run the test again. Okay, perfect. Pretty happy about that. I'm just going to call that hash. And okay, so we turned our test into a ZIO spec. I'm gonna remove this command, and what we can do now is like bubble up this ZIO. So as the handle command is also used by the main, I'm just going to duplicate it for the moment. and call handle command ZIO, which is going to return URIO, I think, that allows to specify just the type of the value that we want to return, not the environment and not the error. Oops. So out of habit, I'm using this underscore here to import everything, but I think in Scala 3 it's actually a star like in Java. So I think the linter corrects that. And I'm going to do ZIO succeed of null command. Okay. So now in my test, I'm going to use this function instead. Let me open the test here. Oops. Let me set it here. I'm going to use this one. So let's see if it runs. So you can see here I'm trying to bubble up the ZIO so we can still, everything still compiles. So we can see a mistake here. Okay. We just want to call the handle command with the actual command, not the same value that we use to call hash here. And saying, okay, so I'm using the wrong, yeah, you can see here that I'm using the wrong ZIO. Actually, the one I need is the UIO, which is an alias for any nothing and A, so UIO. So this approach allows to avoid to have 500 compilation errors when you compile for the first time. Believe me, it happens sometimes. Okay, perfect. So now a test compiles and pass. So if we look at the different files in the file explorer, we can see that we refactored kind of these two files, and the next files to refactor is the main and the main spec. So if we look at the main here, I'm going to open the main here, and the main spec here. Okay. So the main is called handle commands, and the main spec try to capture the console, the output to the console. And we said that this test is not really nice. Sounds a bit weird to capture what's written in the console. So we'll try to improve that as part of this refactoring. And here we are using this feature from Scala 3, which allows to specify which allows a function to be considered as a main, and it's also kind of integrates some business logic for not some business logic. Sorry. It's also integrates the logic of parsing the arguments and giving them getting them in the right type. Here, I believe, which we are not going to have with the ZIO version. So we need to do a bit of logic for that. Okay, so let's start by implement the main here, and I'm not sure we can implement the test for the moment. So I'm going to implement the main, because yeah, I'm not sure we can implement the test without knowing how the main is going to look like for the moment. So I'm going to create the main, and so with ZIO 2 extends, it used to be ZIO.app, now it's ZIO app default. So we should have, just going to import ZIO here. Okay, we can see that we have the main function, the run function to implement here. So I'm going to use println, no, it's printline. So in ZIO 2, there is no more put strlen, it's println now, so we can use hello. This needs to return exit code, I think. Okay, let's see if we can run that. So we're gonna use bloop again, and it's gonna be not root test but root. And the main is at kit.main. Not found print line, fair enough. Gonna import the console. Okay, perfect. So we can see that we can run our main here. What I like to do usually is extract that in a function or in value that I call program. So let me extract that program. Okay, integer is not always okay. Perfect. Oops, not. And if I try to compile again, we should have the same. Okay, so I said that I wanted to have kind of a similar test, a test where we test what is written in the output. And we can do that here in a nicer way here because we're using the console. We have this console objects, console layer that we can use here. You can see that the console is kind of an interface between actually calling println from Scala and the code that we have. So that's great because that means that we can test that we can test that the console is called, the println of the console is called with the right arguments, and trust the console to print to the terminal. We don't really need to check if it's actually printed to the terminal. We trust that the println console is going to print, okay? So when I was preparing this episode, I found a bit of subtlety here because when we call println like that, as you can see, it's written as ZIO, and it doesn't contain, so if I look at the type here, it doesn't contain the console in the environment. So what we have to do, I think, and correct me if I'm wrong, but we have to explicitly say that we want to use the console by here requiring the service. So what's going to happen here is that we're going to say, I want the console to be provided. So if I'm going to show you actually that. So now you can see that in the first here in the first type, the first type here, we can see that the console is required here. So that means that then in our test we can provide it. We can provide a kind of a mock console that is gonna we're gonna be able to use to test that we actually print the right things. But we need to explicitly call the println from the console, obviously. So let's then turn this test into a test that is going to test that we are printing hello for the moment, and then we will we will convert this test into a ZIO test and plug everything. So we want the main spec. We said that it needs to extend ZIO spec default, I think. Default. Let me verify that. Yeah, ZIO spec default. Oops, no. Oh, this is something I despise from IntelliJ. The management of the pans. We said the test and no test assertion. Okay, perfect. So we need that. I'm going to comment that out for the moment, by the way. And we need to implement the spec. So here, what's handy here is that I can call the program. I don't need to call the run here, and I'm going to okay. So I'm pretty happy about that for the moment. We're gonna check if it's actually run, but we can see here that the compiler is saying that there's a problem, and there is this nice error here. So your effect requires service that is not in the environment. Please provide the following type. So okay, it's saying here that we need to provide a console. So great. I'm going to provide the console. So console live. So one thing here is that if we didn't use explicitly the console here, if we just used printed, and what we wouldn't have to specify that it would ZIO would already have that integrated, but as we need to test it explicitly, we need to provide it. Okay, so now let me try to run the git main spec as suspect. Okay, so the provide actually takes Z layer, so I'm gonna wrap that in Z layer. Succeed. There might be another function that allows just to provide the console, but I am not sure. So I'm just gonna use this function for the moment. And as my IntelliJ is very slow, I'd rather prefer use this function than to look for the other function for the moment. Okay. And the same, then we have the same error. We need to provide a console. Okay, so we have one test that runs. Obviously, the test doesn't test anything at the moment, but we are going to be able to work on the mock of the environment, of the console environment, the console layer, in order to capture what's being printed here. So for the moment, I'm just going to create my environment here. I'm going to create a function, provide mock. Actually, I can extract that. So not in a value, but in a function here. And I'm going to call that provide MockConsole. Okay, and I prefer that to be here. If we try to generate a type, ZIO layer of console, please. Okay. So now instead of providing a console live, I'm going to provide a new console and implement generate all the functions. Okay, we can do that in Scala 3. I'm just going to keep with the prices as I prefer that. Okay, so for the moment, we are gonna assume that we just use print line because I think that's what we're gonna use most often. Eventually, we might need to extend this mock. So what I am going to here I'm going to take as an argument ref. So how can I call that? I'm going to call that a recorder. It's going to be a ref of. Okay, so here I'm going to provide the recorder, which is a ref of a case class I'm going to create. So I'm creating a case class here instead of providing a list of string or whatever in which we could add all the print lines, because it's going to be easier for extensibility purposes. It's going to break less code if we need to implement the print or the print error, for instance. So and I'm going to have printed lines. I'm going to use the chunk here of ZIO. just a string basically, and our ref. Okay, so the reason why I use a ref here is that I want to mutate basically the value that I give as a parameter, but I don't really want to have a mutable value. So I'm using a ref here, and I think it also provides some safety around concurrent access. So I'm happy to use that. And the way we can use that is by updating. As you can see that there is an update function. The update function, I'm going to use case here to be able to extract the printed line. So console recorder at console recorder printed line. And what I'm going to do here very simply is saying that I want to make a copy of console recorder, copy printed line, equals printed line. Do we have a function here that could prepend? No, happen, sorry. Happened it. So here it returns any. So I suspect we need to turn it into string. So let's check that appended does what we want. Append an element to the check. Okay, sounds pretty good. Okay, so it sounds like we have something here. So now how can we use it? Well, so to use it, we need to provide this ref that I mentioned. And I'm going to create it here. To do that, I'm calling ref.make, and we said that we want console recorder. So I'm creating it empty, obviously. Recorder with a chunk. I suspect there is an empty method here. Perfect. And recorder. And then I can provide my recorder to that, to the main program. And then I just need to get the printed lines. It's going to be recorder get. Okay, get. Oh yeah, get returns ZIO, I think. So it's not actually printed line, but it's going to be I'm going to call that recorded. And we are going to say that recorded that printed line should be equal to a chunk test. So we are going to make this test fail for the moment to see. And IntelliJ is reporting some errors here. So what's the story? IntelliJ recorder. Okay, I have typo here. the type seems to be wrong. Maybe just console then. And I'd be inclined to just to try to run that now and see what we have. Also, there used to be a mock console in ZIO 1, but I think that they got rid of it in ZIO 2. But anyway, it's not a good exercise to implement the mock console. So what's the story now? Coded.pring. Printed line instead would be better. The compiler is nice, it's giving some suggestion here. Okay. Okay, let's see what we have. Chunk hello was not equal to chunk test. Awesome. We are printing hello here and wasn't equal to chunk test. Perfect. So now that we have the mechanism for our test, so we have implemented the mock console, we are going to be able to actually implement this test. So I am going to actually change these tests to use basically convert the test that I have here to this test. So print the hash of the string parameter. I'm going to explicitly put it to test contents. Okay, perfect. So for the moment, there is actually no string parameter, but we're going to add that later on. And I'm going to put that, the result that we want to check here. So one thing that you can see as well here is that this test is better as well because it's not actually checking what we print to the terminal. Here, I don't know if you remember, but we had to add the return line here to have a test that works because this system also captures the line return. But now we can just specify the actual value that we want to check without the line return. Okay, perfect. Let's get rid of that. I'm going to keep the command for reference for the moment. Okay, so we have a test here, and now let's implement the main. So in the previous main, we were calling the handle command. What we can do here is in our program call the handle command as well. So I'm going to call HashObjectUseCase and the handle command. So in that case, obviously we are going to call handle command ZIO, and because we are using it here inside of a for comprehension, hash object command for the moment, let's provide a test, and this returns so UIO of string, and which is the hash the hash, and we're going to print the hash. So here, let's run this test. So we should see here that we have a different hash because I didn't provide with test content, but only test. Okay, indeed, we can see the two hash. But the test says that we want to give the string as a parameter. And here you can see what we used to have, that for the main there was some kind of getting args that were given in the console, but here there is no way to get that. Well, we don't see any parameters that run here. We actually need to use a special function to do that. This function, I think, is getArg. So here what I'm going to do is I'm going to get the args and provide them to the program. Args get args and then call the program. I can directly call the program. Call the program with the args. And if we look at the type here, so this returns a chunk of strings. I'm just going to directly call that args, the chunk of string. And I am also explicitly going to provide the console here instead of providing in the outer layer, like in the outer out of the 4, because as you can see here, there is some ZIO app arg here that seems to be required to use that, and I'm kind of hoping that ZIO is gonna handle that on its own without me having to explicitly provide that. So I'm just going to, so that's why I'm putting the provide here, because if I put the provide outside, I would need to specify that I'm not providing the ZIO app args as part of this function. I'm just providing the console. And obviously we still need the exit code here. Let's see if we are compiling. Okay, so obviously the test here is not correct because we are not providing the right parameter to program. So let's do that now. Chunk. We say that we want to provide test content. Okay. So it should be happier now. And now we can probably just so let's just provide a head for the moment. So you should never use head, this function head, in any production codes because it throws an exception, I believe. Well, at least for the Scala collections. Yeah, it throws an exception if the chunk is empty. So we never want to use that, but here what we are going to use it, we're going to use it to check that it's actually working. Okay, how it is passing. I'm quite happy about that. I think we're going to stop here for today. We can do a bit of cleanup now. To sum up what we did, we started by converting this test. into ZIO test here. We did that very progressively, so we can compile each step of the refactoring, which is very important. Then we bubbled up the ZIO to this here, and now the handle console shouldn't be used anymore. Well, it should be used only here. So I'm going to inline that. Perfect, and I'm going to rename that to handle comment. You can see that the business logic that we have here is still hasn't moved. We have the handle command, and if I open the main spec, which is open here, we created the MockConsole here using a ref and an implementation of the console and this case class. And we were able to check that the new implementation of the program actually prints what we want. I am conscious that this might not be the most elegant solution. Maybe we'll improve that in the future, because here we need to call to add several lines here to actually get what we want. So maybe there's a clever way to do that. And if I open the main again, so in the main we saw that we can get args with this function, and we are providing those args to our program that provide them to our comments and prints the results. So we are starting to see here that there's going to be a bit of contention here, because we can see that, so for the moment we use head, which should never use, but it's just a temporary solution. We start to see here that we are going to need some solution to handle the command line arguments. For the moment, we only have one type of parameter, but eventually we are obviously going to grow the set of parameters and the set of comments. So we're going to have some kind of command line parser. Yeah, that's mainly it. If I come back to the README, in the CBZ3, we added ZIO with MockConsole. Perfect. So I'm gonna actually commit that. ZIO and MockConsole. And thanks very much for watching. If you have any question or any feedback, please send them in the comments below, and see you in the next one.